No, very excited to close out the day with our morning keynote speaker, so expecting great things from Josh, who is a member of the senior technical staff at Hortonworks and is also a PMC member of the Accumulo project. Josh?
Thank you, Eli. Hi, how's it going? I'm starting to feel it. I'm not used to getting up so early, so we're going to try to have some fun here. Hopefully it'll be informative yet somewhat enjoyable. As Eli said, I'm a PMC and committer member of Apache Accumulo, first and foremost, and happen to be employed by Hortonworks. Some of the other things, I'm also involved with the Apache Slider project, which is going through the incubator right now. And yeah. So what I'm here to talk today about is data center replication, building this sort of functionality inside of Accumulo. What this really means in this context, replication can mean a lot of things. In this case, what we're really talking about is saying, I have one Accumulo instance that I'm going to be writing data to. I have some other Accumulo instance sitting somewhere else. I don't want to have an ingest process that requires me to write that same data to those two instances myself. I want to have this be something covered by Accumulo that when I write it to this one cluster, it's going to make its way to the second cluster. There's a lot of reasons why you might want to do this. And one of the big questions that people will typically ask about, well, why do we even need this functionality? I thought Accumulo was supposed to be redundant. And you're right, we do. Accumulo does make, I'll go as far to say we always make the decision that is going to offer the most resilient failure case for you. So we're always going to make sure that the default that we give you is not going to be losing you data, because in the end of the day, that's the most important thing. Your database can be fast, but it can even be web scale. But if it's going to lose your data after a month, you're going to really have a bad time. But there's a problem with that. Even if you can have this database, Accumulo is great, we can write data to it. An earthquake can take out the data center as long as those hard drives are there. I can bring it back, super. But the problem is, what happened to your application between when that earthquake happened and when you got those new nodes and put those hard drives back in? Suddenly you have this real big problem of your application is dead in the water. You have no way to satisfy your constraints to the users, and it's just as good as losing your data for that point while it's all fine. Some of the things that I've learned, never trust hardware. It is evil. It will fail on you, and most likely it will fail in the most inopportune times. Whereas anytime you give a demo, something will happen badly. There's a couple great war stories that I've heard over the years. From a human error or a human perspective, you always have to consider the case that we are human beings. We all make mistakes. And there will be a day that someday you write rm-rf/star and you nuke a node. Hopefully it will just be one. I'm not so lucky. So that's one aspect of it. The other aspect is, as you're really growing out and you consider something, say you're some startup here, the Argyle Data guys are a great example. They're building this application here. They're building it for people globally wide. They had people in South Korea, SK Telecom, they were doing. They had people, Vodafone in Europe. You're building an application that has this global presence here. One of the good things that you can, if you have never read it, Jeff Dean has a great presentation. I think he gave it Stanford many years ago, where he has a bunch of numbers, and one of these numbers that he gives is a number that every computer scientist should know, he calls it. And the time that it takes to send a packet from California to the Netherlands and back again is 150 milliseconds. So you think, okay, yeah, that's going a long distance. But if you start to think about what that really means to you, suddenly if you have a global presence of users using this database, suddenly it's probably not going to be a good idea if they all have to go across the globe to your one instance in one location. Point being, there may be cases in which geographic distribution of where your data physically sits may be important for latency reasons. And like I said before, this all is boiling down to, is your application available? Are users going to be able to use it when they need to use it? I know, and some of you may not believe me. we have these massive data centers. This is a picture that Google published in one of their own data centers. And you have to think, well, I'm not really going to have a disastrous recovery where I just can't get any of my data, right? I'm running into Hadoop. The files in there, they're replicated once on a rack, or once on a node, and another node in that rack, and some other rack. You're not going to fail across all of them, right? I have some replicas. I'll be safe. And you're wrong. I found that I have a new hobby of now looking up failure cases. They're hilarious. So I just Googled around and found some highlights. Well, a really common one is HVAC issues. So your computers are running in some building, right? And computers are really good at generating heat. And when they're really good at generating heat, you need some cooling. And if that cooling goes away, so do those computers. So even if you start, pretty much if you have some HVAC issues at your data center or whatever, if they go out, the data center is most likely just going to flip the switch and say, boom, your cluster's offline now. We have to get this fixed. And you have some other aspects here. So the other is the act of God, as insurance companies like to call it. Hurricanes, thunderstorms. Thunderstorms, actually, you can find information on AWS, Netflix, Roku, Pinterest, Instagram. All these big sort of Web 2.0 companies who are really going the next level, they've all faced this, and you should probably just expect that they're pretty good about it. And then you just have really fun ones like Squirrels. Level 3 is a network company, and yeah, somehow Squirrels are causing outages in their data centers. So going back to Jeff Dean some more, one of these, in that same presentation, he gives some nice metrics about what you might expect if you have 1,000 nodes, what might you expect to see within the first year of running those nodes? There's a lot of things like, I forget the metrics, and you have some common ones like hard drives will die, network cards will go bad. And typically those, like we said, Hadoop and Accumulo are going to isolate us from more of those, but there are some pretty painful ones as well. In this case, every 2 years, like we said, you're going to have some HVAC issues. And he says you're going to have 1 to 2 days of downtime. Yeah. You're going to have some case where the entire power distribution unit coming into the system that's giving power to your cluster dies. So you need to get a tech in there. 6 hours probably is if you're lucky. Entire racks disappearing 20 times in 1 year. Just 20 to 40 nodes in a rack, gone. And then you have fun things like routers just disappearing, which is probably dozens of racks there. So we kind of tie this back to we have this Hadoop file system. We have some replicas. How lucky are you feeling now that you're going to have enough replicas there where you don't just magically not be able to read data for a while? And of course, the one thing that we haven't addressed yet is the code that you're actually writing on top of these databases. I write terribly buggy code. Eric Newton catches me on it. And you also have things like Grace Hopper, where an actual cockroach or something will show up in your computer. And these are also really fun too. GitHub is actually the one I like the most. They give great write-ups about, remember they had some distributed coordinator, and suddenly they had 2 masters that tried to came up, and it was a shoot the other node in the head policy. So they had some failure condition where the one went down, the other came up, then the first one came up, and then they both shot each other in the head and died. Yeah. So there's a lot of, I guess what we're really boiling down to is here, there's a lot of reasons, both hardware, nature, and software that can all come up to a case that's going to prevent you from meeting your SLA. So you're going to be able to meet the requirements that you agreed to when you said, I'm going to build this application. So this is where replication can come in. What this really means by replication in Accumulo, what this boils down to, is that it's not really much more than a framework for tracking data that was written to a table. So we have key values. When we write these key values into a cluster, eventually we're going to have to send all of those key values to some other locations. Fun part, we could send them to, we could have a single like primary to peer. We could have a primary to multiple peers. We could have fun things where you have 2 primaries both routing to each other. you could have a bunch of things that are, even replicating to other instances of databases, NoSQL or relational. It doesn't really matter. The framework is just at the very highest level, a system to track data inside of Accumulo that was written to a table. In terms of consistency, because we are dealing with a consistent and partition-tolerant database, that's described by CAP, we want to make sure that we don't invalidate those guarantees for the local instance. So the best way we can do this is by architecting asynchronous replication process, and we want to make an eventual consistent. So we don't want to throw away the consistency guarantees on that primary system because that's the one we'll hopefully be using the most. But it's probably okay on the peers if we say, well, if I have some catastrophe and I lose some system, if I have another system that's running an hour, 2 hours, even 12 or a day behind, if I have something, it's going to be a whole lot better than nothing. The other issue, or the other design decision that was made was to take the data on the primary and push it out to the peers, as opposed to having each peer come and ask the primary for data. And the one real big goal is that we want to have it be able to survive prolonged outages. So maybe you have your primary system's running there, something happens and you want to move your peer or your peer is offline for a while. We want the primary to sort of fail gracefully, keep queuing up this data, and whenever that peer comes back and we can start sending it data again, we'll do so naturally. And the only consequence is that we're going to have to wait for that replication queue to clear out. So now the next question is, well, how are we tracking? You said we want to track this data. How are we going to do that? The best use is actually Rightahead logs. It turns out to be the best construct. So for those who need a big table refresher, the Rightahead log is the second part of the ingest pipeline. So the first is the in-memory map, which provides a sorted fast insert data structure on each node. This allows you to get that fast read and maintain the sorted state of a table. The problem with memory is that it goes away if your node crashes. So how we deal with this is that we use this non-sorted append-only file called a Rightahead log. So we can not pay the penalty for sorting it up front, but we can append data to it really fast and still get pretty good ingest rates off of it. The nice thing about this, especially now that they're in HDFS, is that these Rightahead log files are available to all tablet servers participating in the cluster. It's important. So most of the time then, as we're writing in data, we're going to be writing a bunch of data to a table in Accumulo that's going to be tracking this, doing this bookkeeping for us. We have to throw a little bit of data inside of the metadata table, but that's mostly a way to sort of pass data along, and that's really going to nitty-gritty details of Accumulo that made me pull out my hair for a couple weeks. And the other thing we want to be able to use is Zookeeper is really nice for distributing work and not really caring who's going to do it. It's one of those things where we can have, we can take a piece of work, we can say, this is available for use, I need someone to do it. Zookeepers are really great for using this in this case, and we don't really care which tablet server is going to be actually doing the work of pushing this data to a peer. Any of them local should be fine. So, getting down to the details. As you're writing data, like I said, in the normal process, your tablet server is going to write data to the in-memory map, and it's going to write data to the Rightahead log. At some point, that tablet server, when you first start out, it's going to say, okay, I need to go and allocate myself a new Rightahead log. When we do that, it's really simple by just saying, okay, I got a new Rightahead log. Let's record the fact that I'm using this Rightahead log for this table that I'm going to be replicating. So we know up front, okay, we're going to need to replicate data in this file at some point. So as we go, we can go and read this data, and then eventually the tablet server can say, all right, I wrote some data to here, you can start looking at it, and there'll be stuff to replicate for it. So it creates these tables, these records that the master can then come along later and just read it at its leisure. Really what this boils down to is each Rightahead log file, like I said, we're tracking it for a table on that primary system. We know that that Rightahead log needs to be replicated to some number of peers. We don't really care which yet. So the master is what's going to come along, read these records, and say, all right, I know this local table is going to go to some other table on this peer, another table on this other peer, and another table on this other peer, right? So we're going to enumerate all the possibilities of our source to our destinations. The master can then just do that as it's pleasing, just continue to scan and update these records, and eventually it will go through and start saying, all right, now I need to take these individual units of work that are actually point-to-point, saying this file needs to go to this system with this configuration. It can go and replicate this data, and like I said, we can use Zookeeper to do this, and it's great. After a while, when all these replications happen, we send this data across the wire. The tablet servers will eventually report back, hey, replicate all this data to this source. Eventually the master can say, okay, this file is replicated everywhere it needs to go. Cool, let's delete it. So the takeaway there is that over time, we're eventually going to get back to a state where our replication table, where we were keeping all this bookkeeping, is empty. So we're going to have, after all the data is replicated, we're not going to be consuming any extra space on our source cluster. Let's see. Garbage collector. So the garbage collector does an interesting little role, which is a side effect of how the tablet servers actually manage the Rightahead logs. So like I was saying, a tablet server will request a Rightahead log and create one, but the tricky part is that multiple tables could have data in that Rightahead log file. So it makes it a little bit tricky, and because you have to start, like I was saying, you have to enumerate these possibilities up front. But the problem is that you also don't have explicit tracking to know when a Rightahead log is finished being used. The only way you actively know this, because each tablet server, the tablets hosted inside of a single tablet server aren't talking to each other. They're all acting autonomously. And the problem is that there's no record to say, oh, this Rightahead log is never going to have more data appended to it, which allows us to then go along later and say, I can clean up this data, it's fully replicated, right? So the garbage collector is going along. The only way we can do this is actually scan over the records in the metadata table, and we can actually build up a list of files that are no longer in use, and we can mark those as closed, and we can let the sort of replication lifecycle finish. So like I was saying, it isn't, this system, replication as it's designed, isn't so much of a system of replicate data from Accumulo to another Accumulo instance, but it's mainly meant as a bookkeeping system, which has an implementation to replicate to another Accumulo cluster. So we have a nice interface here, a replica system that we can define, say, how do I replicate data from Accumulo to another Accumulo instance? In this case, we have our Accumulo replica system. Now this is sort of the nuts and bolts of what actually does the replication here. These are each running inside of each tablet server. They'll be sitting there, and depending on how you configure it, you could have multiple actively replicating. The general gist of it is you have some local tablet server, and he needs to talk to the remote to figure out who he should replicate to. So he can talk to the master on your peer. The master can come back and say, here's a tablet server that you can talk to, so it sends back an address. So then we have T-server to T-server communication, and it really boils down to just a batch writer at that point. So the primary is sending the data over thrift over to the remote. The remote is spinning up a batch writer and writing it to the table, and suddenly we have data on the remote side. The final step is that the remote side will be doing bookkeeping, and it'll say, okay, I applied this many mutations. I'm going to inform the primary and make sure that it knows that I recorded this many, so we know that we didn't lose any data in transit. There's awkward cases that you might have to consider where maybe that you sent some data over the wire, that remote tried to ingest it, and it died in the middle of it. You want to know that you still can go back, and you're going to have to replay that and retry to replicate that data. So that helps us a little bit ensure some more consistency and ensure that we don't lose data. So the cool thing is that it actually worked. I wasn't too sure for a while, to be honest with you. It was a couple weeks of a lot of head down work, and it was actually pretty cool when I actually got it working. It was one of those days where it was like a eureka moment of I ran a test and it actually did what I expected it to. The nuts and bolts of this is that it will be included as a part of Apache Accumulo 1.7.0. It will also be released as a part of the next version of the Hortonworks data platform, HDP. And right now it's sitting up in its own branch in Apache, and you can go check it out. I've been keeping up to date. it has some reviews, but it's hard to get someone to look at 20,000 lines of code, minus thrift. So what I have at the bottom here is I set up a little system at home where I had one computer that was set up to replicate to another. I ran 2 T servers on both, and I just started spinning up our continuous ingest test, which just slams a bunch of data. So what you can take away here is, in the top here, I don't know if you can necessarily see it, but the first table here is essentially saying that I have a local table. In this case, it's called CI. I'm going to replicate it to some peer whose name happens to be peer. I'm using the Accumulo replica system, because I'm replicating another Accumulo cluster. And in this case, we know we have 7 files that need replication. Down below, we can actually see the progress. So I have 3 threads that are active that are going to be replicating this data. So what we can see is we have a brief overview to say the file that's being replicated presently and the number of mutations that have presently been replicated for that file. So the idea of what's next is interesting to think about. One of the things that we've talked about for a while is the ability to automatically sort of write data from one system from Accumulo to another system. It comes up often when we're talking about HBase comparisons because we don't really want to learn to write both APIs. We'd much rather it just work for us, and then we can do our own benchmarks a lot easier. It's funny enough, I remember somebody telling me once with HBase, I was talking to some guys about this, and they said they actually had a customer who was interested in replicating data to MySQL. But we'll see what actually comes of this. It might be interesting for my own purposes, I'm interested in seeing HBase performance, and if I can make it easier for me to get the data in both places, makes my life easier. Sort of an implicit note about the using Rightahead logs. If you're astute, you would have noticed that if I'm doing bulk imports aren't using Rightahead logs. So yes, you're right. If you bulk import data into a table, it would not be replicated as it currently stands. In practice, this wouldn't be too much work to actually implement, but the merit from actually implementing that might not be so much. If you think about it, if we go back to what we said earlier, we don't want to sit there and write data using a batch writer to multiple instances because that actually incurs a lot of CPU time on your ingest client. When you're doing bulk loading, it's typically you're running some batch job already. You're using MapReduce to generate these large sets of files. And most likely, if you generate them once, it's pretty darn easy to just copy them to another location as well before you bulk import them. So it's a lot easier to say, I'm going to replicate this bulk ingested data to multiple locations at once rather than trying to shove it through this. But it would work. Keith asked me, actually I think it was Christopher, asked me once, what about conditional mutations, this new feature in 1.6 that allows me to only write a value into a cell if some column condition is met. That isn't going to work right now. The way that's implemented right now, if you think back, we have this asynchronous model where we're going to be lazily replicating data. The problem is that to do a proper consistency check, you can't do that asynchronously. So it's possible we could come up with some way that we could have some sort of failure condition. I'm not entirely sure. I haven't thought about it a lot. Like I said, I was rather surprised this worked in the first place. The final point is an interesting one that I haven't quite thought through completely either. A common practice that you have with Accumulo tables, if you have some sort of custom iterator or combiner, some table configuration set where you're doing some sort of aggregation automatically, doing it at compaction time through this. It's a pretty common practice. And most times it would be really nice that you could say, okay, I want that configuration to be consistent across all my systems, right? If I have a copy of this table, I want it to have these iterators set. The downside is that also can bite you. Consider if you have 2 systems. One is your active and you have a backup. Most likely the actual physical specs of those 2 systems are going to be different. Your primary one is probably going to have more nodes. They're going to be a little less beefy. They might have more RAM than disk. Where your backup, you're going to be much more disk heavy. You're going to have less compute, less RAM resources, because you really want to optimize the amount of data you can store in the least number of nodes. As such, other things like the time to live on some records, it's going to change. So if you have, maybe you want to automatically age off data on your primary longer, but you don't have enough space to keep that same amount of data on your peer, so you need to configure it differently. Not really sure how that's going to work, but it would be an interesting discussion to actually think through and see if there's a way that we could automate this. I'm also obligated to give a huge thank you to all the devs who put up with me consistently asking questions for many weeks on end. If you're interested, the Jira is up there. It's probably a lot of gibberish, but it's there. And that's all I really wanted to go into, but if anyone's interested, I can start going into details. I didn't want to bore you with how we read from Rightahead log files or stuff like that. So I figure if anyone has any questions, open up. Christopher.
How does the data get played back from the Rightahead logs and sent to the peer? Is it the entire Rightahead log set, or are you just playing back the data from the tables that are configured for replication?
So the Rightahead log is a fun file. Like I said, it contains multiple data. It contains data from multiple tables that essentially what was the tablet server hosting at the time that it used that file. As such, you can have lots of these fun little identifiers in there that actually align to, you have to figure out a mapping of saying this mutation with this special identifier maps back to this table ID, and that's how you know what data needs to be replicated, right? Or that's how I know what table those mutations came from. So what we really do there is that the process in the tablet server is just going to rip through that file. And like I said, this is a point-to-point concept now. We have a single tablet server that's replicating this data to a single peer with a table ID there, right? So the way it does it is it's just going to go and read all the mutations for that, for that peer. And it's not going to be sending all the extra cruft inside the Rightahead log that has all these notices like when a major compaction happened, when a new tablet split, all these sorts of fun gibberish that you don't want to really know about. So the short of it is just the mutations are sent. The local tablet server is smart enough to read through and print out the other stuff that's happening. The downside, of course, is that you could hypothetically be rereading that file multiple times. But in cases where you have some peer that's offline, we don't want to stall replication to a peer that is online because one of the others is offline.
My main concern is that you're not sending data for tables that are not configured for replication.
Yes, I'm sorry. That was I meant to imply that. It's the mutations that are sent are only sent for the table that is currently being replicated. So if you have mutations in there that are for some other table, just get ignored. Whew. Let's go. Let's start. Yeah.
Okay.
I'll get to one more.
So really quick, have there been talks about to capture the corruption of data when, can this, whether I'm replicating data that's corrupted, or is there a way to kind of know that a block is corrupted that I'm trying to replicate across and stop the replication right there?
So,
Notify that something is wrong.
so the DFS client will give you some notification of that already, right? Down in the weeds, the DFS client is doing checksums, I think, on like every 4K bytes or something like that. So you're going to know, and Accumulo is going to bail out way before you actually even get the data off the DFS client, and you're going to get something bubbling back up through like I think it'll either transparently try to read other replicas of that block, or it will just throw back up and say, I can't read any replicas. All of them are bad. So there isn't anything specific in this implementation that would prevent that, but it shouldn't be happening in the first place from HDFS.
So I feel like it's not a stupid question. I hope it's not.
No stupid
In the
questions.
event that the destination tablet server dies, or the initial communication with this accumulation, does the Rightahead log then grow without down until it comes back? And you have a long catch up, or is there some
On the primary?
on the peer side?
On the peer side. So when a tablet server comes back up from recovery, what it's going to do is it checks the metadata table and it sees, okay, I have some logs that are sitting there for this tablet that I'm trying to bring online. that's how it knows to kick off the recovery process. So you're going to have some data there, and after that process is complete, it's going to pull a new write-ahead log file for itself. So it will cycle those files. If, hypothetically, if you get in some loop where you continually try to replicate and that destination tablet server just keeps repeatedly dying, it's just going to be re-rolling new write-ahead log files each time, and the garbage collector will be cleaning up the old ones after they get recovered.
Okay, and while it's down, the garbage collector will see those.
Yep, because they'll be still referenced in the metadata table. Oh.
Could this be used to do migration data from one cluster to another live, like from old cluster to new cluster, without taking server offline?
No. You can actually get that already. You don't, so that's a good point to make that I didn't make. Because we're using write-ahead log files, this isn't doing anything. You'll never be replicating data that already exists in a table before you configured it for replication. So that data is already sitting there in our files. The reason why you don't need it for doing, like you said, if you're migrating an old table to a new system, something like that, is because you can use a combination of a clone and the export table and import table, which is going to be much more efficient than this will be. So you can make a snapshot of your table so you can know at a point in time, I configured replication, so all data moving forward is going to be replicated, and I know that, and then all the data from that point back, I know I can export from the clone and import it on the new.
So you wouldn't use to replicate all your data, but you could use it to make sure that things are
Right.
being up to date
Mhm.
before you do the import of everything.
Right. Yeah, sorry, there's two of you sitting by me. Yes. So how does, so the question is, how does the client get notification that the file has been synced to all peers? Mm-hmm. So remember, this is an asynchronous process, right? So the client is not going to be waiting at all for this data to be replicated. So what's really going to happen is that I added a couple of little operations there that try to allow you to make an invocation that will just wait until all the data that needs to be replicated at the time that you invoke that method is done. If you just try and wait for a table to be fully replicated, if you have any ingest coming in there, you're constantly going to have a situation where you're replicating more data and you're going to have a call that never finishes. But the short of it is your normal batch writer shouldn't at all be affected by this pipeline or these changes. In front.
My question had to do with encryption and security.
Mm-hmm.
I tweeted Michael Allen earlier. How is this encrypted when the data is at rest and at transit? Like, is this covered by those encryption APIs?
So encryption at rest, you'll be. I believe you're in here. The write-ahead logs are encrypted using the same mechanism that the R files are using. Okay. The obvious problem is that you're going to need to share those keys across. The remote side is going to be able to need to deserialize and read that, right? I probably have a hole in that sending it. Now, one of the things for wire encryption that I actually still need to do is set up. Getting into the details on the implementation, the way Michael did it was actually by wrapping the thrift connection itself. So when he did it, he actually did it really nice because it doesn't change anything in the client land, or client being the server in this case. The tablet servers their API didn't change on how they invoke writing files and stuff out, or how they sending data across wire. It just happens naturally. So that's one minor thing I still need to do. And again, that comes back to both sides need to be aware. They need to have the proper keys in their trust store, key store, whichever one of those. Yeah.
Or SSL, but they also need to share the
Yeah,
file
right.
encryption, the key encryption keys, or whatever management system you have
Right.
in place for where keys.
Yeah.
If that's all good, then it should all just work.
Yeah. So in the current state as is now, yes, you would be leaking data if you were going over some unsecured WAN, yes. But I should be working on that in the next week and get it done. I don't anticipate it to be. Yeah. Let me go ahead.
You said there's a little replication piece in there. Does that allow you to plug in, let's say, a replication out
Yeah. I can touch on the configuration. I glossed over that because I hate looking at configuration slides. The crux of it is you configure replication when you're dealing with accumulo to accumulo, you're enabling replication on some primary of a table. So I'm saying this table on my primary is going to some table on another system. And then that is tied to some implementation, which in this case would be the accumulo replications, blah, blah, blah. Hypothetically, I'd initially thought about trying to do it at locality group, but that gets really hairy and wonky when you try to actually filter out that data again. So right now you can configure if you just want one table to be replicated, if you want one table to be replicated multiple places, if you want to multiplex many tables to many peers, the configuration parameters is in your court. Being invaded. Anything else? Oh, I'm sorry. Sure.
Can I do a switchover, like a right switchover?
So, like if you have two systems set up and one of them dies, right? How do you do that?
I mean, not a failover, but switch swing back to one and switch over.
So that would be outside of the scope of this, right? So all this will do is really saying these two systems will be eventually consistent between each other, but the application logic to actually direct queries to one system or another, that is built at a different level. So same thing. It's not addressed by this. Yeah. Right, because in some cases, you do expect a certain amount of failure within a single cluster, right? If a T server dies, you don't want to just go and say, oh, you're going over here. It's left as a manual thing because there's going to be a lot of other extra application logic that you're likely going to have to build in anyways.
Similar question. Is it, you see use case for being able to replicate data that matches certain authorizations like that?
Absolutely. I mean, it's very well a use case that you want to consider, right? If you have some data you have some system that has some sensitive records in it, right? You want to replicate it to some other location, but maybe the accreditation of that system is less. I don't have that built in right now, but there's nothing that would prohibit you from adding that into the configuration of a system to say, I'm going to replicate this data only if it matches these criteria of authorizations or something like that. I guess I should probably quit.
Let's go.
Thank you.